Okay, so these AI technologies are seen as something that can benefit society. That's why they're in this chapter, and they probably will. They probably do now. It's just a matter of being able to measure it, but it's not going to benefit everyone. Okay, so robotics. Okay, robotics is not new. I guess what's new about robotics is the instructions that guide their actions. There have been robotic applications in assembly plants for decades and decades. It's a branch of engineering that involves the development and manufacture of mechanical or computer devices that can perform tasks that require a high degree of precision or that are tedious or hazardous for human beings, such as painting cars or making precision welds. Well, I guess in the evolution of robotics, something that is distinctive today, though, is that many of these robots do look human, or they perform acts that seem to be human acts, like jumping, moving around, playing ball, things like that. The use of robotics is expanding and, of course, will continue to grow. But robots don't have the capacity to make moral judgments. These need to be programmed into them. Okay, and here's a real short clip about this.
So let's say you have to read an incredibly long email from your boss that you have to finish before the big...
Hello friends, I welcome you all to TechMite. I hope you all are doing well. Today's video is about robotics. Almost all of you have heard this term, and most of you might have studied about it. Let's do a quick revision together. Starting with the definition. Robotics is the intersection of science, engineering, and technology that produces machines, called robots, that substitute for or replicate human actions. A little bit more common term than robotics is robot. A robot is the product of the robotics field, where programmable machines are built that can assist humans or mimic human actions. Robots were originally built to handle monotonous tasks like building cars on an assembly line, but have since expanded well beyond their initial uses to perform tasks like fighting fires, cleaning homes, and assisting with incredibly intricate surgeries. As technology progresses, so too does the scope of what is considered robotics. In 2005, 90% of all robots could be found assembling cars in automotive factories. These robots consist mainly of mechanical arms, tasked with welding or screwing on certain parts of a car. Today, we're seeing an evolved and expanded definition of robotics that includes the development, creation, and use of bots that explore Earth's harshest conditions. Robots that assist law enforcement, and even robots that assist in almost every facet of healthcare. While the overall world of robotics is expanding, a robot has some consistent characteristics. 1. All robots consist of some sort of mechanical construction. The mechanical aspect of a robot helps it complete tasks in the environment for which it's designed. 2. Robots need electrical components that control and power the machinery. Essentially, an electric current, a battery, for example, is needed to power a large majority of robots. 3. Robots contain at least some level of computer programming. Without a set of code telling it what to do, a robot would just be another piece of simple machinery. Inserting a program into a robot gives it the ability to know when and how to carry out a task. Let's talk about the uses of robots. Robots are largely used to perform various tasks and to make human life easy. They are widely used in manufacturing, assembly and packing, transport, Earth and space exploration, surgery, weaponry, laboratory research, and mass production of consumer and industrial goods. We will discuss their uses in detail in another video. Till then, stay connected. That's all for today, guys. If you liked the video or learned something, then please support me by liking it, sharing it, commenting on it, and subscribing to TechMite. If you want to see helpful and informative posts on technology.
Okay, so what do we have left? We have natural language processing. And this, since the early days of AI, this has been regarded as an important subfield. It's a field of artificial intelligence that involves technology that allows computers to understand, analyze, manipulate, and/or generate natural languages such as English. It's more than just a machine understanding what you're saying or a machine talking to you. Part of natural language processing is the analysis of text, where you can feed text into a machine and it can infer the tone of the text. It can infer not only the meaning of the text, but characteristics of the person who wrote it based on the frequency of word occurrences and things of that nature. So let's take a look at this. I think Dragon was one of the very first natural language understanding applications that you could buy at a store. And gosh, that must have been 10, 15 years ago. And it was really clunky. You had to train it just like you have to train contemporary NLP apps, but it didn't work very well. The applications are much better today, of course.
Star Wars fans would be familiar with the golden life-size hospitality robot, C-3PO. While Star Wars might be set in a galaxy far, far away, the reality of having machines talk and respond to us in a human-like manner is already a reality, which keeps getting more and more realistic with every passing day. The people you ask for queries on websites, your smart assistants, even calls made over the internet, all of them have one thing in common. None of them are actually human. Now, you must be thinking, if they are not human, how do they manage to sound and seem so human-like? How do they respond to me so intelligently? And how are they so articulate? This, my friends, is the magic of natural language processing. What is NLP? Natural language processing, or NLP, refers to the branch of artificial intelligence that gives the machines the ability to read, understand, and derive meaning from human languages. NLP combines the field of linguistics and computer science to decipher language structure and guidelines, and to make models which can comprehend, break down, and separate significant details from text and speech. Every day, humans interact with each other through public social media, transferring vast quantities of freely available data to each other. This data is extremely useful in understanding human behavior and customer habits. Data analysts and machine learning experts utilize this data to give machines the ability to mimic human linguistic behavior. This helps save millions in terms of manpower and time, as you don't need to always have a person present at the other end of a phone. NLP is also a lot more widespread than you may realize. You use it every day in seemingly normal and insignificant situations. Don't know how to correctly spell a word? Autocorrect has you covered. Need to see if your article or thesis will get flagged for copyright violations? That's okay. A plagiarism checker will search through the web and find any cases of published documents which may match your work line by line. While NLP seems really cool, yet a cutting-edge and complicated technology concept, it is actually pretty easy to learn. You start off with a document or an article. To make your algorithm understand what is going on in it, you need to process it into a form which is easily comprehensible by the machine. This is no different than making a child learn to read for the first time. You start off by performing segmentation, which is to break the entire document down into its constituent sentences. You can do this by segmenting the article along its punctuations, like full stops and commas. For the algorithm to understand these sentences, we get the words in a sentence and to explain them individually to our algorithm. So, we break down our sentence into its constituent words and store them. This is called tokenizing, where each word is called a token. We can make the learning process faster by getting rid of non-essential words which do not add much meaning to our statement, and are just there to make our statement sound more cohesive. These words, such as are, and, the, are called stop words. Now that we have the basic form of our document, we need to explain it to our machine. We first start off by explaining that some words like skipping, skips, skipped are the same word with added prefixes and suffixes. This is called stemming. We also identify the base words for different word tense, mood, gender, etc. This is called lemmatization, stemming from the base word lemma. Now we explain the concept of nouns, verbs, articles, and other parts of speech to the machine by adding these tags to our words. This is called part of speech tagging. Next, we introduce our machine to pop culture references and everyday names by flagging names of movies, important personalities or locations, etc. that may occur in the document. This is called named entity tagging. Once we have our base words and tags, we use a machine learning algorithm, like naive Bayes, to teach our model human sentiment and speech. At the end of the day, most of the techniques used in NLP are simple grammar techniques that we have been taught in school. Here is a question for you. Which of these NLP techniques is used to obtain words from sentences? A. Stemming. B. Tokenization. C. Lemmatization. D. Segmentation. Give it a thought and leave your answers in the comments section below. 3 lucky winners will receive Amazon gift vouchers. With the increasing demand for automated language solutions, companies are looking for NLP experts to join them and are prepared to offer highly lucrative salaries as well. If you want to learn more about NLP, you can check out SimplyLearn's postgraduate program in AI and machine learning in collaboration with IBM. In this program, you will learn about frameworks like Keras and TensorFlow and get hands-on experience in deep learning to become a truly experienced AI engineer.
When it turns into an ad, it's time to stop. That's pretty cool.